All right, we're in 2.7 and I'd like to do number 9 with you. So this is the second video on composition of functions. And again, just want to call your attention to some notation here. When we're adding two functions, we can add them as either f plus g of x or whatever their name is. And we could write that as f of x plus g of x. We could write it when we're subtracting f minus g of x. We could also denote that as f of x minus g of x. And then just a little bit about the domain. A domain A that belongs to F and a domain B that belongs to G. This is read as domain A intersect B. And finally, when we're dividing a composition of functions, we've got to remember that we cannot divide anything by 0. So we might have to graphically take a skip over that hole in the graph. And that's good enough for a beginning explanation. So let's actually look at some functions to combine. So here we're going to do everything. We're going to add, subtract, multiply, divide. A whole slew of operators. And I always like to do these little pencil ones. I assume they think that's a really good one for the instructor to do. So I will. All right. So here's my f of x. So I'm going to do f plus g of x. And that's going to give me a 1x squared plus a 1x. And then g of x, I think I'll switch color for g of x, is going to be plus another 1x squared. All right, and now I've got a 1x squared and a 1x squared. We're going to be doing some addition, so we just add them and don't do anything with the powers. It holds. That's going to give us a 2x squared plus a singular x. And we are done. Not dividing by anything. The domain, when it comes to quadratic, if you remember, quadratic goes from negative infinity to infinity. And you can, of course, graph this on Desmos and check that out. I don't think I will right now. You can. All right, so the next one is we're going to do f minus g of x. So f minus g of x. Nothing's changed here. We're going to have f of x is 1x squared plus a singular 1x. Only this time we're going to be subtracting an x squared minus a 1x squared. Okay, so combine like terms. 1x squared minus itself goes to 0, and we're just left with 1x. All right, same thing for our domain. We're going to have a negative infinity through an infinity. All right, that's a linear function, 1x. Okay, let's do a multiplication. So f of x times g of x, or we could write it as f times g of x. All right, we're going to have x squared times x squared plus x. So distribute. X squared times x squared is x to the 4th power, product property for exponents. And then x squared times x to the 1st is an x cubed. And again, if you want to graph that, do it. It will be a domain. So there's my domain. Domain of negative infinity, non-inclusive, because infinity is not a value, it's a concept, so you can never include it. You can't capture it. You'll never reach it. Negative infinity to infinity. Okay, but now we're going to have a hole in our graph because we're going to do a little division. So we're going to say we want f of g of x. So last problem is going to be f of x divided by g of x. And f of x is x squared plus x. And g of x, just double check, is x squared. All right, so I'm going to use the distributive property, take an x out of the numerator, and that leaves me an x plus a 1. And then I'm just going to break up for you to be able to see clearly that x squared into x times x. So that's really what it is. And once I do that, I can simplify this. X divided by itself goes to 1, and I can simplify that to x plus 1 divided by x. All right. So now when you're talking about a domain, if x happened to be 0, well, that's going to be an impossibility. We cannot divide by 0. Therefore, our domain, we're going to come from negative infinity. We're going to reach 0, but we're not going to include 0, so we're going to use a rounded bracket. Then we're going to hop over and have a union on the other side of 0, non-inclusive, and we're going to go all the way to infinity. And there you have it. So I hope that helps, and that was combining functions 2.7, and we did number 9 together.